That's one of those really interesting things that's emerging is some of the companies that are on the vanguard of deploying this stuff are getting just a lot smarter on how do they understand whether this thing will work for them in their setting that they care about and what things they should index on or what evals and kind of almost integration tests they should run. It's that type of the kind of shift from getting it to work to saying, okay, how can I have a program here where I control the inputs and outputs in the way I need to, I can serve it, I can dictate the behavior of the model more stringently, all that. The kind of quintessential use case for AI and agents that everyone's been chasing ever since ChatGPT, every enterprise is not fully established, is trying to, but people have made a lot of progress, is trying to basically build their own ChatGPT that is aware of their own company's internal data, internal context.
Jared, thanks for joining me today. Good to see you, my friend.
Hey, great to see you, Spence. I'm looking forward to this. Always great to...
Yeah, I've been looking forward to it as well. So let me start with asking about you. So I admire you a lot. You founded a company while finishing grad school. You do some public science, so you write publicly. And while we were talking just before this, I found out you learn languages for fun and you speak Chinese, Japanese, and Korean. So my first question is, when do you sleep? How do you manage all of this?
Yeah, that's extremely kind, but yeah, it's quite, it's a fun time to be alive. I'm pretty lucky that, I grew up in the era of the internet and I've very much indulged and taken advantage of that and kind of really found my own intellectual interest and found things I'm super excited about, super animated by. And yeah, that's some of those fit really, really neatly in domain boundaries, like the stuff I did my PhD in, but some of it is kind of adjacent to that. And I kind of indulge in all of it, at will somewhat. And yeah, it's pretty fun. I think now, there's never been a better time to be an autodidact and to like to learn things. And cause there's just so many resources at our disposal. So it's quite a bit of fun. And, it's also cool that we're so leveraged that every time we learn something, it's a lot easier to take your learnings and use them somehow. And so, things I didn't even imagine would be useful, like some of the languages end up being useful because now we run a company that has customers all around the world, including in Korea and Japan, etc., and works with suppliers and such in Taiwan. And, so it's pretty global business, but then also obviously we're sitting at the intersection of, AI and systems, but then also working with customers in a lot of downstream domains who are trying to figure out how to deploy AI in their context. Right? And everything from, financial services to science to a broad range of science applications to a lot of classical business. So it's actually kind of nice to, I think, find all that stuff interesting and animating. It makes it a lot easier to, go to work.
Well, let's talk about one of those interests, which is the company. We're a customer. We think it's awesome. Our research team loved it. So, give us the one sentence about ML Foundry and what problem you solve, and then we'll kind of go from there.
For sure. Yeah, I think the public cloud, as it exists today, was built for the web and for web workloads. It was built in 2003, the first public cloud, and a lot of the assumptions, both implicit and explicit, were only valid for web workloads. And so part of what we've done at Foundry is say, how would we envisage the public cloud if we were building it end-to-end for AI workloads? And how would the business model change? How would the scheduling model change? Kind of up and down the stack. And doing that has allowed us to create a model that allows us to make things a lot more reliable, a lot cheaper, to have kind of preemptible work and such, handled and interweaved more naturally with long-term allocations. And long story short, it allows us to fulfill the kind of promise of the public cloud around elasticity and availability, but in the AI cloud context, where that kind of promise of the public cloud is currently not really being fulfilled. People are forced to do long-term reservations. The costs are prohibitive. There's a lot of complexity that companies have to wrangle themselves. And so we're trying to chip away at that and making some progress along a lot of dimensions. And, it's pretty cool. The company, still young, but we've been helpful to, I think, a pretty broad range of entities now and growing really rapidly. And so it's a fun thing. And quite a bit of room left in the agenda too, which is very inspiring.
And are most of your customers enterprises, like enterprise machine learning teams that are training models, or are they startups that are making products, or where's your main customer base?
Really great question. So our main customer right now, it spans, the way we define it actually is kind of along maybe two dimensions. One dimension is, are they more AI practitioners or AI developers? Or are they more developers who want to use AI? I'd say our customer set at least right now, is much more kind of AI developers. So that's one distinction. And then the second dimension, I'll explain why. And the second dimension is, at what phase in the development lifecycle are they? Are they at kind of very earliest phases where they're trying to build initial prototypes and or are they at the phase where they've kind of got the kernel of something that's interesting, they have a research agenda they're committed to, and they want to scale it up, invest behind it, and kind of run a research program, run a production serving program. And I think we're slightly more that kind of more mature phase for the AI developers. And, in terms of AI developers, partly it's our own DNA to focus on AI developers as opposed to someone to use AI. That's partly just where we come from. Doing research at labs like DeepMind or in our PhDs at Stanford. And so I think we understand the problems that are most acute for that type of persona. And that persona exists across enterprises, academia, and startups, of course. And then on terms of the scale work, a lot of what we focused on was we went directly for cost and elasticity first as a major problem to address, trying to remove some of the economic impediments to doing large-scale AI work. And that's a problem that you only feel when you're starting to invest at some scale. Like if you're doing a very early prototype with AI, you're not cost sensitive. You're just trying to get something to work. But if you're trying to run a research program or put things into production or do things at scale, then you start to care about the economics and the ROI. And that's where it becomes useful. So, and that's naturally where we started. But we're building right now, we've been building kind of a really, really solid and novel infrastructure as a service layer. But our business has been expanding and we're starting to actually say, okay, let's go a little bit up the stack and actually even address some of the challenges that our customers face even earlier in their agenda. Because many of our customers have one project that's in the mature stage, but then other projects that might be early where they're trying to get something to work. And so we're trying to help them a little bit with that too. So we're branching very strategically in a couple of different directions, but our kind of core ICP, are those kind of AI developers trying to, run an ambitious program, put things into production, scale things up, who really care about cost and economics.
So this podcast is broadly about adoption of AI, mostly in business contexts or in enterprises where you're trying to use AI models to do some job that's useful to customers downstream, internal customers, external customers. And you get a really nice, interesting view into that because you see the types of workloads that these businesses are running. And I'm curious about, I think there's one view of the world, which is just, if you're a business and your core competency is not building AI systems, then just use APIs. But it sounds like you're finding inside businesses, there are teams that are training models themselves for different things. And you get to kind of see that to the extent you can share what kind of models customers are training and what are they using them for? And what are the problems that are coming up with, the models that they've pre-trained or post-trained, and then they're trying to get them into production to do some useful job. Like what do you find most interesting or surprising of the types of use cases that your customers are attacking?
Yeah, really, really phenomenal question. I think there's maybe 3 phases to work, and it makes sense to distinguish between them a little bit. So the first phase that is a distinct part of the customer journey is the kind of early validation or experimentation phase. And I think a lot of companies, they start off and they have some concept of what they want to build, and they're trying to get a first prototype of that thing. And I think at that stage, customers are not price sensitive at all. Before you care about cloud cost optimization, you just want to kind of, you're trying to even establish that the cloud is something that works for you, for example. Or in the case of AI, they want to build a demo and they're going to grab the most powerful model they can build. They're going to do things in a pretty bespoke way, perhaps in Colab notebooks or even using, prompt hacking and a GUI. They're not trying to systematize it or serve something at scale and really build kind of a scalable program. They're trying to validate that this is a concept where they could apply AI or deploy an agent or something. And so for that, I think that definitely, a lot of that work starts with an API. It starts with the most powerful reasoning model or the biggest model that they can find from a closed source model provider, whatever is the state of the art. And in fact, I think at that stage, people are often building compound systems where they're making many model calls or composing models across providers into some kind of consortiums and ensembles. And they're just trying to throw as much horsepower as they can. They don't care if it's $10 per call. They're just trying to make the thing work. and I think that's like one extreme, and things start there. From there, the phase after that is where we meet a lot of our customers. They're either after that phase if they're in the enterprise, or they're kind of dedicated model developers with their own research agenda. And they've now gotten something to work, and they're trying to think about, okay, how to make the ROI of this work, how to scale it up, how to have a bit more control over the outputs and, over the system, broadly speaking. And that's where I think they start to get into, dealing with their own models from a bunch of different angles. Sometimes it's as simple as they want to build their own compound systems or fine tune and then serve open source models. And they basically want to have the pipeline be around open source models so they can run it on-prem with their real customer data, things like that. If it's a language model use case, right? And so it's that type of, the kind of shift from getting it to work to saying, okay, how can I have a program here where I control the inputs and outputs in the way I need to? I can serve it. I can dictate the behavior of the model more stringently, all that. And so there's this evolution from validation to, I think the next phase is kind of scale up and program establishment. And then from there, it's kind of a serving and almost maintenance type of agenda. And so I think that's a bit of the evolution. So we see people doing a lot of things, like some of the use cases that are definitely interesting and popular, retrieval and QA. It's just one of those kind of core use cases that I think is almost going to be very persistent, where people have.
Is this being used for like search use cases based, some kind of, yeah.
Exactly. Search, so one, the kind of quintessential use case for AI and agents that everyone's been chasing ever since ChatGPT, every enterprise is not fully established, is trying to, but people have made a lot of progress, is trying to basically build their own ChatGPT that is aware of their own company's internal data, internal
Ask
content.
questions of your business.
Ask questions of your business. Like that's just a classic thing that everyone's trying to, build various subsystems for and build a system for.
Yeah.
Right. And so that's classic, and there are many components to that. Like there's a lot of batch work where they're trying to pre-process all their documents into embeddings or into they're doing agentic RAG or classic RAG, so there's compute work of that flavor. There's obviously the models themselves that are actually reading the content, and they're trying to maybe distill them, make them smaller so they can read more, or, trying to improve the fidelity, right? There's a lot of work of that form, right? That's a classic use case. Another classic use case is definitely kind of code and, developer productivity.
Oh, businesses are training their own code model because they don't want to share their code base.
Yeah, exactly. In some cases, they don't want to share their code base, or they have classical code. Like, for example, their business is a lot of old code.
They've got a load of Ada 83 or something, and they've got it.
Exactly. Some Fortran, some kind of classic code, and they're trying to, post-train, a model to be better at translating that from classic code to some new language, or understanding that and wrangling it. And so they've tuned that a bit and found that to be a high leverage thing to do. So that's another kind of big thing, is definitely developer activity, so that's an exciting case. I think another just broad theme that's pretty common is kind of distillation. I think we're like, okay, here's a use case I plan to use a lot. Let me see if I can take some capability that maybe exists in a large model. Maybe they have a Llama 405B variant, and they want to basically just get better and better at squeezing that core capability, whatever is a subset they care about, into some even smaller variant. And that's kind of a continual, workload that I think is manifesting. And so, I think that those are some core themes. And a lot of that, the work that I just noted, was kind of in that, going from experimentation to establishing agenda at scale. There's another kind of very emerging but still nascent area of work that's popping up, which is almost a new class of work, which is training these router models, like these compound system component models.
I want to talk about that. We'll come back to compound systems.
We'll come back to that.
Yeah.
But that's another kind of workload, which is actually funnily, can be actually really useful. Training reward models, process reward models, verifier models, or even trial and just router models that are good at looking at a query and then saying, which API even should I send this to?
Yeah.
That type of model. So it's getting really interesting, I think.
A theme through a lot of these is data security. And so maybe what's driving this for businesses is they don't want to send their code base or all of their, enterprise data that's behind various permission systems. They don't want to send that off to an API or put it through a pre-built product. Like, for the search use case, you got like Glean, ChatGPT, Enterprise, Notion AI. There are like lots of these that are kind of pre-built now, but you see for big businesses, they want to they think it's valuable to build that for themselves.
Yeah, it's a good question. I think there's a mix. Like there's some companies that are definitely sensitive about the security aspect of it. I think there's some who just feel like, you know, they trust their own, maybe for political reasons, but also, their teams, like they trust their own team's ability
Yeah.
to hone the models for their own internal setting or their own use case and kind of to hone the agenda. I don't think they start there for the demo. So I think in that phase of trying to go from zero to demo, actually, I think a lot of people work with other companies. So they'll work with OpenAI, they'll work with Glean, they'll kind of get things going and they'll continue to be big users of those entities in the future. There are some kind of big accounting firms or, that, for example, have done this. Like they're massive users of Azure, OpenAI, and have invested a lot in that. But then also they said, okay, we kind of realized, hey, we got it going. We're massive users. If we want to scale this further, we're going to need to have our own first party capability. Because otherwise the ROI will start to get a little bit challenging. If we want to expand the set of use cases or open up that next use case that currently is just beyond the frontier of making sense, etc. And so they start to say, okay, we're already spending 9 figures, or eight, like 9 figures, 8 figures at least, on Azure OpenAI and, consuming this. And we built a lot of things that are really useful and it's getting consumption. How do we then take this to the next phase? And so that's what they're thinking about, okay, distilling, further post-training, maybe moving from OpenAI to a custom Llama pipeline, that whole framing. Even NVIDIA has talked about this actually publicly. They've talked about how they use a lot of fine-tuned instances of Llama as their internal kind of agents.
Yeah.
Because, they can take the base model and distill it on, and then fine-tune it rather on a lot of very specific data. And they like that control and they kind of really just overwrite a lot of capabilities really aggressively. It makes a lot of sense to have that control. They kind of fork then those base models even further and build their own kind of internal directory of, model versions. And then they'll distill those and they kind of have built their own system around this. And so I think businesses are doing more things like that for enterprises, which is cool to see. Like, I think that is a common basically process of going from the best closed source thing you can find, then saying, okay, now I want to own my agenda. Let me then build on top of open source models, build something a little bit more proprietary, build my own post-training stack, and then kind of go from there.
We got to compound systems, but you used the word agent. So I'm really glad we got to this because you were
challenging.
One of the folks on the Berkeley, the Berkeley AI Lab blog post about compound systems, which was a very sensible, article, very, sort of like modular systems engineering approach to different ways to use multiple inference passes or put models in either in parallel or in series in different ways to break tasks up, which is a really sensible proposal. And this has turned into, we can have digital labor for like any job that one might imagine. So from the person who was on the paper, I would love for you to say, what is an agent in your view? And then what are the types of things that businesses now should think about using compound systems or agents for? Like you were just talking about, you see, the NVIDIA case is a good one of distilling models down for very specific types of tasks. But like, what is an agent from a computer scientist perspective? And how should we then think about that in business?
Yeah, the term agent is...
It's obviously an old term from Russell and even before that. Like it's an old term in machine learning and artificial intelligence, right?
Yeah, it's been extremely overloaded in this current context, and it's pretty fraught. I do think we need to put some work in as a community to kind of distinguish between these things a bit and to try to create some more, rigor around definitions. Where we started with compound systems, I think there are many different kind of sub-ideas even in that theme. That's just kind of describing even an entire kind of class of research that's emerging as what compound systems is. But, there are kind of a couple maybe motifs that we can, anchor on. One of them is this notion that you invoked of multiple inference calls instead of just thinking of these models as a monolithic kind of constructions. I think that's a really, really key one that we noticed and wanted to kind of highlight as almost like a pattern of thought that people should bring to their problems. One of the recognitions that spawned this was one of the most famous papers that my team at DeepMind worked on is this paper called the Chinchilla paper, right? Which looked at scaling laws and how you should distribute, if you have compute and data and parameters, how you should basically think about the optimal ratios of these things. But that paper, I think one of the gaps in it was very focused on training. And the scaling laws it derived were about kind of the efficiency of your training protocol. What it didn't really think about was actually it makes sense sometimes to be really inefficient in training, to overtrain a small model, wasting money at training time to make a small model smarter than it should be, in air quotes, so that you can then serve that small model really cheaply and you have a lot of portability and flexibility
Right.
in terms of where you serve it. So it's like that whole dimension of like, not just thinking of monolithic model calls and evals in this very unidimensional way, but rather starting to think more about like the life cycle and kind of broader cost. That's like one piece, which is really critical. To that same point, I think relatedly, bringing this ROI, almost value lens to things, the notion starts to emerge where a very common pattern that I think people were, in a very bespoke way were building was they would kind of take these kind of state-of-the-art models and just try calling them many, many times if they had a high value problem. And they were trying to almost build reasoning systems themselves. And so they would do one common pipeline is you just make multiple calls and then see if the two calls agreed. So I know a company, for example, that has a very simple system where they're trying to do document extraction. They make two calls. They have a kind of a hand-stitched compound system where they make two calls to a language model to do the document extraction. They see if those two calls agree exactly. If they agree, they say, sounds good, and they pass that on as done. If they diverge, then they send it to a BPO, like some organization, where a human reviews it. Right? And so that was their system, And that was kind of a bespoke thing. That was two calls, obviously very, very kind of simple system, but that's an example. And then, so that's another kind of archetype is you have like a problem that is high value where actually you're willing to pay more than the cost per token, of one of these state-of-the-art models, but you have the kind of quality or reliability frontier that you're looking for is beyond the frontier of these existing models. Like, how do you kind of reach that frontier early and get GPT-5, GPT-6 early? That's a whole nother class of problem. And so that's another kind of key theme. And this is, understanding that there's different, like a kind of entire tapestry of SLAs, like there's latency, cost, and then different dimensions of quality all in the mix that people are thinking about when they're trying to deploy these things. And like, how do you, first off, start to create structure around like, what are some primitives in this broader space that we can study and make claims about? Is there any structure here? Is it all just hacky trying things? That was some of what we were trying to start to look at in this work. And by calling this an area, it's like, okay, yeah. So that's a key piece of it. I think with agents, that's part of it. Like this reasoning notion, inference time compute,
Yep.
making multiple calls is a part of it. There's also tool use as a part of it. It's kind of a very, overloaded concept. But I think broadly, one of the patterns that's emerging is I think people are saying it's not just a single model. Like there's entire process and scaffolding around the model. Either it's neurosymbolic, meaning you have some classical program dictating the control flow and calling the models, or it's agentic, meaning there's a language model dictating the control flow. It's kind of maybe one distinction that I've seen that actually I kind of liked, where it's more agentic if there's a language model that's doing all the orchestration, breaking everything down and dictating the control flow. And it's more of like a, neurosymbolic, almost more compound system in some other sense if you have like a classical program where the language model is a component.
Yeah.
That's maybe one way to think of it, which actually I think, okay, that's not perfect, but it seems like an improvement.
Yeah. One way I've thought about it, there's the kind of engineering way of compound systems of just, multiple inference passes. I like the idea of two inference passes and see if they two, agree. That's a very simple one, but you could imagine it'd be very powerful. The other way is sort of the arc of how software development has kind of gone, where you had sort of custom built systems, I don't know, in the 80s and 90s or something, and you would build a system for your particular use case, and that was like really tuned to whatever you were trying to do. And then we had SaaS, where then it was like, buy Salesforce and that's the CRM for everybody, but it doesn't exactly match their use case. So then you got to have like custom developer support or, try to match it to your use case. And now it's almost coming to you can, with chain of thought, you can have an agent sort of for whatever I want to do, sort of map out a workflow for me, and I can follow that. So it's almost like an adaptive user, it enables some kind of an adaptive user interface.
I see exactly what you mean. Yeah, that's a powerful notion. One of the things that I think we're starting to notice as we're seeing more and more adoption of these things and these, richer workflows with many LLM calls and such coming into play is I think it's revealing a couple of gaps along a couple dimensions. Like one is how we do evaluation. Another is the depth and rigor of our systems thinking about these things. Another is just like broader gaps in our even research agenda and how deeply we understand, how these things interact and how we can piece them to solve some end objective. Maybe as a starting point, just to see if this is interesting, like I think the evaluation is a key one. The way we evaluate these models right now is, I'll use a very crude sports analogy. It's kind of like the combine in the NFL, right? It gives you a picture.
Yeah.
You know what I mean? It's like,
they're kind of two things that have emerged. You and I are from similar backgrounds where, maybe even 6-7 years ago, it was virtuous to just look at a benchmark, like look at the results table and like, don't even look at the output of the model, even though some people would look at outputs of models, like the clever people for better model building. But then now that it's like mainstream, like vibes, the vibes evaluation metric, actually kind of matters a lot to people. And so we've got still the legacy of like scoreboards, which is actually how you make progress. It's really important to have a benchmark that you make progress on. But for actual users, the vibes check, and companies can actually orient their entire evaluation program around vibes check and outputs that are more pleasing to a user for a particular use case. It's just so antithetical to my training that it's, even though like, I build products now, but it's still kind of hard to think about.
I totally agree. And I think even gnarlier than that, though, is in many cases, actually, these models are being used as components in a broader system as opposed to giving us an output directly.
Yeah.
So the most common workflow, like that we can, I think, illustrates this point is one really common pattern that everyone's using in some form is just ensembling. Either with a single model or cross models. And you have some model that maybe is your ultimate judge that is mediating the output, but then you have many models that are feeding that with candidate propositions. That's a really common workflow. And one actually funny thing about that is that's almost more like a team. Like it's almost more of like a Moneyball type of evaluation than the combine, or either on vibes dimension or on this kind of, scores dimension, because the contribution of a model isn't just its own capability. It's kind of its effect on the overall set. And so ironically, one very simple example there is we actually like models for ensembles that are a bit more variegated or diverse in the outputs.
Yeah, they're diverse. Yeah, you want diversity in an ensemble, of course. Yeah.
Exactly, right? And that's a different dimension. Like that doesn't pop up on a best of, on some other evaluation.
Yeah.
Or even in vibes per se.
Yeah.
And some of the models that are really good are a lot less diverse in their outputs than others.
Yeah.
Like Claude is actually really, really well aligned, which actually means that it's kind of more predictable, it seems, in its outputs in some measurements than other models, which actually makes it less useful, perhaps, if this kind of the core component in an ensemble.
Yeah.
On its own, at least, right? So it gets interesting. It's like, it's a very different form of evaluation, a different way of thinking about it. We talked about this earlier, like multi-turn evaluation is also a bit different, right? And so I think that's one of the things that everyone's kind of figuring out, and a lot of the companies are on the vanguard of, is saying, okay, evaluation really doesn't work in the classical sense. Like the eval scores that people are showing me don't necessarily correspond to performance on my downstream task. And so I think that's one of those really interesting things that's emerging, is some of the companies that are on the vanguard of deploying this stuff are getting just a lot smarter on how do they understand whether this thing will work for them and their setting that they care about, and what things they should index on, or what evals and kind of almost integration tests they should run. I think that's really cool to see emerging. But that'll be challenging, and that's like a problem that I think the AI research community is not thinking about as much. Like the AI research community is thinking of it kind of in a relatively one-track way. Trying to optimize metrics, like, to use that terrible combine analogy, the 40-yard dash or whatever.
40-yard dash. Yeah. It simplifies things down. You can sort of benchmark a lot of things that are going on by, it's sort of like, I don't know, the FICO score or something like that. It's this kind of crude metric that, everybody knows it. So you can kind of, or NPS or something. There's all this literature that it's not a very good evaluation, but it's something that you can benchmark against, basically.
I think that was actually one of the things that I respect a lot about OpenAI, and the breakthrough they made in 2022 with ChatGPT was the kind of RLHF, post-training breakthroughs that OpenAI made when they got, they took these language models that they already had and other companies already had. But I think part of their breakthrough was saying, can we train it to be helpful, to follow instructions?
Yeah.
And I think part of that metric, at least the way I see it, was part of what they were saying was actually the core evaluation is, does a user like this output?
Yeah. I think that's
Like
exactly right. The instruction fine-tuning paper is still very counterintuitive. Like, well, it makes sense now, but I think it would not have been within the space of things I would have even thought to do were I, sort of sitting there in 2020 or I guess this was like, basically 2021 or something like that. But yeah, it's an odd thing to try, but if you come at it from like, how do I make this AI system more helpful? Then I guess it's like kind of a straight, it's almost sort of an obvious thing to think about. Yeah.
I agree. Right. And, so it's very interesting to see this emerging. Like that's kind of one big bucket. I think, to that point, it's getting a lot more interesting in terms of people saying, okay, like I've seen people do some really interesting work where they're training models specifically to be good at verification or to produce outputs that are highly verifiable.
Yeah.
Right. Because they're trying. So it's not just, for example, it's almost like training a teammate to not just be smart, but to be a good communicator, because then they work better as a team. So you're kind of getting the models to expose more of their thinking and produce outputs that are easy for even a small verifier to check. And so I guess, it's kind of a little bit of the Wild West in the short term. And I think people are just defining these tasks in their own way. And there are kind of a couple of key themes and motifs that are emerging, like, okay, best event is a good thing to do. Invoking many calls when you have a problem that, where you care enough about the outputs that you're willing to pay that extra cost is a smart thing to do. Like there's a couple of themes emerging, but I think overall it's still, there's not like some shared notion of a really, really good hill to climb, a really, really good North Star that captures the myriad of things that we care about, that people are all running on. So it's interesting. I think one of the things that I'm excited about over the coming months is I think the field will start to optimize, and Mike Jordan at Berkeley talks about this really nicely, actually, start to look at more of like a collective view as opposed to an individualist view, is what he calls it, of kind of AI systems. And we'll start to, think about the, systems interacting, and that will become kind of an emerging field, emerging scientific discipline a little bit.
Yeah.
And, so that'll be fun.
Well, I've enjoyed this conversation a lot. Can we close up? I like to close up with two quick questions, or sort of QQs, if you will, if we were texting each other. So short answers to these questions.
Sounds good.
And would that be all right?
Yeah, that's perfect. Sounds
all
like
right.
a plan.
So here's the first one. So, okay, so you're leading a company now. So what's your advice to like aspiring leaders, maybe people who want to found a company or want to lead people? Like what's your top thing that you would advise them to do from the experience you've had so far? Yeah,
I think the top thing to me is to have an anchor, to like be, to be grounded. And for me, that's staying really focused on like what vision is exciting to you, in your thesis for what needs to happen for that to manifest, among things that need to happen, what's not happening, and then where can you move the needle, and just repeat that to yourself in every scenario, both at the level of the company and its strategy, but then also in terms of what you're doing and focusing on day to day. Just focus on like making a counterfactual contribution and make that your focus. Don't worry about, like a lot of other things can be confusing, but if you're just saying, okay, here's where we're trying to get to, you define that and you make sure everyone's aligned around that. You then identify and call out your thesis. Then I think everything becomes easy. So I'd say just have an anchor and focus on counterfactual contribution. And then, market position, hiring, everything else will follow.
I think I'm going to use that after we get off this call. That's great advice. Yeah. What gets you excited about the future?
I think it's pretty cool. Like I think the future looks more positive sum than it's ever looked in my life. Like, I think the most important thing in the world, in a company, in any dynamic, is that people believe things are positive sum. And I think the future looks really positive sum. Like I see a path to us solving some of the most pernicious problems across education, health, transportation. It's a pretty inspiring future that we've got in front of us. And yeah, it's like everything's kind of happening at once. Like all the things that were sci-fi, humanoids, self-driving cars, drones, like fusion,
spaceships, AI,
spaceships, like like it's all kind of happening, which it's quite amazing. Like it's remarkable like how many things seem to be overlapping. So that's pretty exciting. Like it feels like everything's possible. It feels like, it's all going to happen. Like we can all make it all happen. It feels like the future will be really positive sum. And, that's quite cool.
Yeah. All right, Jared, thanks for this conversation. Great to see you again.
Yeah. Thanks, Spence.
All right.
Appreciate it.